So, to begin with, let us start our discussion by trying to understand the concept of a rigid body. So, first, let's try to understand what is an ordinary body. So, let us assume that we have an ordinary body shaped like this, and we apply some forces to this body, let's say F1 and F2. And these two forces, F1 and F2, are quite heavy in magnitude. Heavy enough such that the shape of the body deforms to this particular shape, which is denoted by these dotted lines showing this figure. So, due to application of F1 and F2, the shape of the body deforms. So this kind of observation is pretty common mostly with all the bodies that we encounter in everyday life. If a pretty large amount of force is applied on those bodies, the shapes of those bodies deform. So here comes the concept of a rigid body. So how do we define a rigid body? We define a body to be a rigid body in which no matter whatever we do, no matter whatever magnitude of force we apply in whatever direction, the shape of the body is never going to change. So, if this particular body shown in this figure is rigid, and let's say we apply a force F1 and a force F2 to this body, no matter whatever be the magnitude of this force, no matter how large is this force, the shape of this body is not gonna change. So now this definition that we gave for a rigid body is pretty physical and quite qualitative. So now let's try to think a more deeper, and let's try to give a much more precise and scientific definition to a rigid body. So how do we do that? So we define a body to be rigid if distance between any 2 points inside the body should always be constant. So let us try to understand this with the help of this figure. Let's say that we have a rigid body shown in this figure, and here we consider a particular point shown by red color. Let's call this point P1, and let's consider another point, let's say P2, and let's say the distance between these 2 points is D. So we are gonna call this body a rigid body is no matter whatever we do with this rigid body, no matter however force we apply to this rigid body at whatever point, the distance between these 2 points, distance between any 2 points in the bodies, let's say this particular point and this particular points, distance between any 2 point in the rigid body is always same. It is never going to change. So the distance between these 2 points is always going to be D. If we consider this point as P3, the distance between this point P1 and P3 is always going to be D2, let's say. So the distance between any 2 points, no matter wherever we consider the points in the body, is always going to be constant. Now, in this chapter, we are interested to study the motion of a rigid body. Broadly, the motion of rigid bodies are classified into two categories. These are translational motion and rotational motion. So let's try to understand each one of these in detail. So what is translational motion? Translational motion is the type of motion of a rigid body in which the orientation of the body does not change. So let us think that we have this rigid body and we try to move this rigid body in this fashion. Let's say we are moving this rigid body, but clearly in this form of motion, in this type of motion that this rigid body is having right now, the orientation of this rigid body is not changing. The orientation of this rigid body always remains the same. So again, let's try to define translational motion in a more scientific and mathematical way. So we call a body is having translational motion when the velocity vector of each and every point residing inside the body is same. Consider this particular figure. In this particular figure, we can see that the velocity vector for each and every point inside the body is same, because in this particular figure, for each and every point we can see the velocity vector that is indicated by these green colored arrows in this figure. In these arrows, the length of the arrows is same for all the points. Also, the direction towards which each of these arrows are pointing is also the same. So the velocity vector of each and every point residing inside this body is same. So we can say that this body is encountering translational motion. That is, this body is having a motion in which the orientation of the body is not changing. Similarly, in this particular figure, we can see that the magnitude of velocity vector is same for all the points, as the length of the arrows is same for all the points, and the direction in which all these arrows are pointing is the same direction. So we can say that velocity vector for all the points are same. So we can also say that this particular body is also having translational motion. Now let's try to understand what is rotational motion. So rotational motion is the motion of a rigid body about an axis of rotation such that different particles of the body move in different circular paths with the centers lying in the axis of rotation. So let's try to understand this with the help of this figure. So here we are given with a rigid body, and here I am considering 2 points. Let's say this point is P1 and let's say this point is P2. We are assuming that this entire body is rotating with respect to this particular axis, and we call this as the axis of rotation. So whenever this particular rigid body is rotating with respect to this particular axis, this point P1, we can say that this particular point is rotating in this circle. Similarly, this point P2 is also rotating along a circle, and both the circles have their center located in the axis of rotation. So each and every point in this rigid body is individually is rotating in a circular path, and all the centers of all those circular paths are located in the axis of rotation. So in this particular chapter, we are primarily going to study the rotational motion of rigid bodies, and we are going to study the rotational motion of rigid bodies in great detail. Now, once we clearly analyze and understand the concepts of translational motion and rotational motion, we can analyze any kind of motion of a rigid body. What we can say is any general motion of a rigid body can be assumed to be a combination of translational motion and rotational motion. Let me try to explain this with the help of an example. So, let's say that we are given with a particular rigid body, and this rigid body is moving from this particular location to this particular location to this particular location. It's simply translating from here to here, and this is the path traced by one of the points located in the rigid bodies. Let's call this point as P1. So this particular point T1 is tracing this particular path, and this rigid body is simply translating from here to here, and it is following this particular curve while translating, and we can clearly see that the orientation of the body does not change. Now what we assume is, while this body is translating along this particular curve, we assume that there is an axis of rotation attached to this particular point, let's say P1, and this axis of rotation, here is the axis of rotation, and this axis of rotation is perpendicular to the plane of this screen. So It's perpendicular to the plane of the screen. It's coming out of the plane of the screen. And while this body is translating from here to here, this body is also rotating with respect to this axis of rotation. This is illustrated in this particular figure. So while this body is moving from this location to this location, with respect to the axis of rotation, it is also rotating. So as the body is translating, it is also rotating at the same time with respect to an axis of rotation. So this is the axis of rotation, this is the axis of rotation, this is the axis of rotation. The axis of rotation is also translating with the body, but simultaneously, along with translation, the body is also having rotation with respect to an axis of rotation. So what is the combined effect? The combined effect is that we are having a net motion of the body, which can be thought of as a combination of rotation as well as translation. So we can clearly see that the body is moving from one location to another location, and as the body moves from this location to this location, the orientation of the body also changes. From the upcoming videos, we are going to study the rotational motion of rigid bodies in great detail.